Hi, today we will be doing a banked turn problem. So the problem is we have a turn with a radius of 80 meters that is perfectly banked for a car moving 75 kilometers per hour. We are looking for the coefficient of friction mu for a car going 94 kilometers per hour. Before we do any physics, we're first going to convert those two units into meters per second, the standard unit for velocity. So 75 kilometers per hour is 20.8 meters per second, and 94 kilometers per hour is 26.1 meters per second. Alright, now, the next thing we're going to do is draw our free body diagram for this car. So we're going to draw our car, and the forces acting on it. So we have the force of gravity, or mg, going straight down, and our normal force going up. We're going to call that n, and we're going to set our sign convention to be up and to the right is positive. So now we're going to do our summation statements. So we're going to do forces in the y direction equal to n cosine theta minus mg equals ma equals 0. We're going to rearrange that for n. So we have n equals mg over cosine theta. And what we're looking for in this first part right here is we're trying to find the angle theta before we can work on finding mu. So now we have our force in the y direction. Now in the x direction, we have the forces in the x direction equal to n sine theta equals ma. And since it's going in a circle, we know that the acceleration equals v squared over r. So ma equals mv squared over r. Now we have mv squared over r equals, we're going to plug in n here, so mg over cosine theta times our sine theta. Alright, now our m's cancel out. So we have v squared over r equals g times sine over cosine, which is tangent. Now we're going to divide both sides by g, so v squared over gr equals tan theta. Now since all of these variables are known, so I grab my calculator. Alright, so I'm going to plug in the numbers here. So we have our tangent equal to tangent equals 0.5518. Now to get our angle from this, we're just going to do tan inverse of that, which gets us an angle theta of 28.89 degrees, or I'm just going to use 29 for the rest of the problem because it's easier. If this was the AP test, you would want to keep your sig figs. Alright, so that's the end of part 1. In part 2, we will be doing the math to actually find the coefficient of friction.